grade 6, how are you? Hope you're all doing well. Today we're going to be talking about lesson 2, forces in motion, and we're going to be identifying everything that comes with it. So please pay attention to the slideshow carefully. Alright, now here are the objectives of the lesson. We're going to be identifying what a force is. We're going to be identifying Newton's laws of motion. We're going to be focusing on his first law of motion. We're also going to be identifying that Newton's first law of motion can be also called the law of inertia. And we're going to be identifying a type of force called friction. And we're going to be identifying how velocity and acceleration are related, and what net force is and how to calculate it. Alright, now here are the instructions on the PowerPoint. You have to read each question, then watch the video, read the summary written, and there's a question for you to complete on each slide. Please complete it and then submit it back on the Edmodo. And at the end, there's going to be an online assessment on Edmodo. This is when you're done with the whole lesson, you complete it, please, on the Edmodo. Alright, now on page 394, it talks about motion and position of an object. First of all, watch the video and then read the summary. This summary states that every object, we can describe its motion if it's moving. We can describe it by using the words, for example, jump, roll, move, lift, bump, and so on. Now, an object also always has position, so we can describe an object's position for also using the words away, up, against, above, down, and so on. Alright, now look at this question. It says, look at the picture below. Describe the skier's motion and position. So look at the skier's motion. How is it moving? How do you think it's moving? Use some words to describe its motion and look at the skier's position. What do you think about the position of the skier? Also use those words that we just said to describe his position. Alright, now page 395, it talks about inertia, Newton's first law of motion. Now Newton's first law of motion states that an object at rest tends to stay at rest and an object in motion stays in motion unless an unbalanced force acts on it. Now, do you remember grade 6 when we talked about balanced forces? We said if forces are balanced, the object stays at rest. And we said, grade 6, if forces are unbalanced, that the object can move or it can change, right? This is what Newton's first law of motion states also. And we can also call it the law of inertia. So it can also be called, instead of Newton's first law of motion, the law of inertia. Alright, look at question 2. It says, look at the picture below. So you're going to be looking at the marbles. Explain in terms of forces how you can make these marbles move. So if we wanted to make these marbles move, grade 6, what do you think we have to add to them? Do we need to give them balanced forces? Or what do you think we need to give these marbles for them to move? Alright, now page 396, friction. First of all, again, watch the video and then read the summary. Now, friction, grade 6, is a type of force that acts on two objects that are in contact with each other. So in order to have friction, the object's surfaces need to rub against each other. Now, look at the examples. For example, when you rub your hands against each other, we have two surfaces rubbing against each other, one hand with the other hand. So there's definitely going to be friction. And the next example, a sled sliding across on snow. When a sled is sliding across on snow, the surface of the sled is rubbing against the surface of the snow. So there's also friction. And this is why the sled tends to slow down and eventually stop at the end. And the box being slid across the floor. Let's say grade 6, you did not want to hold the box. It's very heavy, so you slide it across the floor. There's going to be friction because the surface of the box is going to be hitting against the surface of the floor. And it will eventually also stop due to friction, right? Okay, question number 3. It says, look at the picture below. Explain why the ball will eventually stop rolling. So grade 6, imagine that you had a football in your hand and you rolled it against the floor. Why will the ball eventually stop rolling? So talk about in terms of force, why the ball will eventually stop and it won't keep going on and rolling. Alright, page 397 now. acceleration. Also watch the video and then read the summary, and I'll be explaining it to you right now. Acceleration is the rate at which velocity changes. Grade 6, do you remember when we talked about velocity and we said it's basically a given speed with direction? Okay, so that means that there's acceleration on an object, acting on an object, if the speed changes or the direction changes. So if an object's speed is changing or its direction, then that means the object has acceleration, or we can say the object is accelerating. And acceleration can be measured by meters per squared. This is the unit for acceleration. Do you remember grade 6 when we talked about speed, the unit for speed, it's meters per second, and the unit for force, it's Newton? So the same thing for acceleration. The unit is meters per second squared. So when we calculate acceleration for an object, we need to always put meters per second squared when we calculate. Okay, now acceleration depends on two things, the size of a force and the mass of an object. So the greater the force we add on an object, the more acceleration. And the less mass an object has, the more it's going to be accelerating. So imagine we have two boxes, one weighing, one that has a mass of 100 kilograms and one that has a mass of 50 kilograms, and we gave them the same exact amount of force. Which one will move more? The less massive one, right? Okay, and this is basically related to what I just said. Question number 4, it says, look at the picture below. If the same amount of force is added to the two shopping carts below, which one will accelerate more? Explain your answer. So look at these shopping carts. They are the same, they are given the same amount of force, but one is empty, so it's going to be less mass, and one is full, so it's going to have more mass. Which one will accelerate more, grade 6, if we give them the same amount of force? Think about it. Alright, and now we have net force. Grade 6, and also we're going to identify, other than what net force is, how to calculate it. So here we're going to be calculating, okay? So listen carefully. Now, first of all, I want you to watch this video first before reading the summary in order to know how to calculate. First, let me tell you what net force is. Net force, it's basically all the forces acting on the object. So if an object has many forces acting on the object, this is how we get the net force acting on one object with all the forces acting on it, okay? We can have many forces acting on an object within the same direction, or we can have many forces acting on an object with different direction, all right? So I want you to pay attention to this example very closely, all right? Now we have two forces acting on the couch, 25 Newton going to the right and 20 Newton going to also the right. So when we have two forces acting on an object that are going to the same direction, and these are going the same direction to the right, we add them. So what we do to calculate the net force is 25 Newton plus 20 Newton equals 45 newtons to the right, because the forces are both going to the right and they're going the same direction. So that's why we did not subtract them, we added them. All right, now I want to show you an example of forces that are acting on different directions, opposite direction. Look at this example. Look at the kids. They're pulling a rope, okay? We have two kids pulling to the left and two kids pulling to the right. Now in this case, we have forces acting on opposite direction, so we calculate differently than the first example. We calculate this one by subtracting. So there's the total force going to the left is 320 Newton, and the total force acting on the right is 300 Newton. Now, we also need to determine the direction. How can we do that? Is by seeing which one has more force. The one going on the left has 320 Newton, and the one going on the right has 300 Newton. So the direction will definitely go to the left because it's 320, so it's more than 300. So now we know the direction, which is left. So what we do is we subtract 320 minus 300, which equals to 20 Newton. And we said the more force is going to the left, so we
say 20 Newton going to the left. However, grade 6, if the force was more on the right, we would say 20 Newton to the right. But actually, it's the more forces on the left, so that's why we said 20 Newtons to the left. So do you understand how we know when to subtract and when to add? Based on if they're going, again, in the same direction, we add, and if they're going in opposite directions, we subtract them. And this one is for you to do. Now you can try it on your own. I think it will be easy for you. Question number 4. Look at the picture below. Calculate the net force acting on the car. Remember that the forces are acting on the car are opposite directions. So this one, you use the second example that I told you about the kids on the rope. So what you do is you see which one has more force acting on the right or the left. That way you'll know your direction, grade 6. And then you either subtract the forces or add the forces based on which directions they're going, opposite directions or same directions. All right, grade 6? And thank you. I think this is all I want you to know for this week. And please let me know if you have any questions